Hi everyone, welcome back to part 2 of our solution for Namaste SQL's free tier SQL problems. We have already solved 7 problems from the start. If you haven't watched the first part, go ahead. I will encourage you to watch it and then come back where we will tackle all the rest of the problems today. So without any further ado, let's jump in. Okay, so today we will start from category sales part 1. Let's see, let's read out the problem, we'll create a plan and then we will execute it. Okay, so write a SQL query to retrieve the total sales amount for each product category in the month of February 2022, only including sales made on weekdays, Monday to Friday. Display the amount in ascending order of total sales. Okay, all right, so we have ID, product ID, category, amount, order date. Okay, it's seemingly simple problem. We have this is the table, ID. Oh, no, sorry. No, this is the table. Yes. ID, product ID, category, amount, and order date. This is the table. And then there will be expected output. I think it will be at customer level, right? Product category level. I'm sorry. This will be at product category level and total sales. That too, just the sales that happen on weekdays. So this makes sense. First of all, what we will have to do, we will have to play around with the order date here because that's the only date column that we have. So first of all, we'll have to filter for only February 2022. On top of it, we'll only have to pick out the days, which is Monday through Friday. How do we do that? So for that, we'll have to use some, let me change it to MS SQL first, and then we'll have to do some date formatting function. We'll use all of that. So let's go ahead. First, the way I'm thinking about this is I will create a weekday column here separately from order date, and I will only filter the weekdays from the table and also only the dates which are falling within February 2022. After that, we will take category as group by column, and then we will take a sum of the amount, and that's it. That's all we have to do. We do not need any subquery or CTE here. But let's see. Go ahead. Let's start tackling the problem. We will need a sum of amount as total sales, right? And then we will need category first. This is the grouping column. Category, sum of amount, and that's it. We don't need anything else. We need sales, where order date, month of that. So let's take date part. How is the date structured? 2022-02. We do not even need date part. I think we can use left function here. Left is a string function. This is date, but should work just fine. Let's take order date, comma. We need to take the 7 characters from left, right? 7 characters should be equals to 2022-02. And that's it. That's all that we need. And what do we need? We need weekdays to be Monday through Friday. So let's say date, weekday, comma, order date in. So what happens when you take the weekday function within date part, it will give you the output from 1 through 7. Now 1 usually signifies Sunday, okay, until and unless it's in your system, it's specifically customized. So in here, most likely 1 would be signifying Sunday, and then 2 through 6 would be Monday through Friday, and we do not need Saturday, so 7 is also out. So let's just signify or mention 2, 3, 4, 5, 6. And yeah, then we have to group by category. That's it. Let's run code and check. Okay, we did get something. Books, clothing, and electronics. Yeah, perfect. I think this makes sense. Close, perfect. Now what happens, just to give you an idea, in let's say in production or in any production environment in any organization. So if you have weekday and you're trying to map it from 2 through 6, that's fine. Also, you might be able to either use case when to signify what does 2 mean in your data, because the business will need it in term of how Monday performed, how Tuesday performed. They don't understand what is 2, what is 3, what is 4. So either you have to use casevent to create the values of 2 equals to Monday, 3 equals to Tuesday, etc., or there'll be a separate mapping table or a bridge table which will automatically have this values, and with correspondence to that we will have the actual weekday values as well, which is nothing but Monday, Tuesday, and so on and so forth. So that's how we actually use it, but hopefully you understand this. Let's go to the next question. Okay, so this one is done. Yep, let's go to category sales part 2. Okay, write a SQL query to retrieve the total sales amount in each category. Again, the same thing, include all categories. If no products were sold in the category, displays as 0. Display the output in ascending order of total sales. Okay, so we have to write category sales to be 0 if nothing else. Fine. Okay, so for this, we will need to kind of have we need to use a trick, if I may. So what does it mean? First of all, if you just take a overall, take a group by category ID, total sum of amount, that's also fine. But let's say any category ID which does not have any sales, they will not have any amount. So you won't be able to display 0. So what happens? Usually you will have to have a separate table which is already created here. All the category ID and category name separately created. If it was not, we had to create a temporary table where we will store all the categories separately, and then we will probably do a left join and then have the total amount mapped to all those categories. Anything which is null, that will be replaced by 0. That's what the usual approach would be like. Now here, since a separate table is already given, so our effort will be lesser. Okay, so understandable category ID, there are only 4 categories, then there are some sales ID and so on and so forth. Let's go ahead, let's remove this, and then we will try. Now let's take directly, we need, what I'm understanding, we just need, oh yeah, expected output is also given, category name and total sales. That's it, that's all we need. Let's use category name, right, comma sum of amount, right, as total sales or something. Yeah, total sales. Okay, fine. From, so we will use categories table as a left table here. So categories as C, left join sales, yeah, sales as D maybe, or S, on C dot category ID equals to S dot category ID, right? So we're done. Category ID, sorry. And on top of that, we'll have to, yeah, just use a Qualys here. Okay. Qualys is essentially the particular keyword which in case of a null, it will automatically replace by your default value. In our case, we are giving the default value as 0. If it's sum of amount, great. If sum of amount is null, then we will replace it by 0. That's it. That's all we need. Let's group by category name. Here, I'm not using S dot category name, or sorry, C dot category name, S dot sum of amount, etc., because both the columns are coming from separate tables. In case you have common column names in any of those, corresponding tables, you'll have to specify which table you're taking it from. In our case, it shouldn't matter. So yeah, that's it. Let's run code. Oh, we have to order by something. Order by ascending order of total sales. Okay, so total sales ascending. Perfect, should be fine. Yep, let's evaluate. Correct. So we're done with 2 problems. Let's move to the next one. Walmart, penultimate order. Okay, let's go. Okay, you are a data analyst working for an e-commerce company responsible for analyzing customer orders to gain insights into their purchasing behavior. Okay, perfect. Your task is to write a SQL query to retrieve the details of the penultimate order for each customer. Okay, got it. Penultimate means last but one. Now, however, if a customer has placed only one order, you need to retrieve the details of that order instead. Display the output in ascending order of customer name. Okay. Just the order ID or something. Okay, order ID, date, customer name, product name, sales. For each customer, there will be only one order ID. Okay, I think I'm getting a strategy. What I will do, maybe, so for each customer name, I can create a column saying what's the total number of order they have placed. If it's five, and then keep five. Create another column which will rank all my orders in like with respect to the order date, and any rank which is minus one from the overall order count. That's the order that I want to take, and anything where my total order count is 1, we will just take that particular row. We'll either take where count equals to 1, that particular row, or we will take those rows where my rank is -1 from the overall count. Yeah, I think this will work. Let's go ahead and work on this. I do not need a CTE here. I need the overall everything. Yeah, I need everything. Let's select star from orders where hmm okay, order by sum of, not sum, count of order ID or sorry, over partition customer name. Apparently customer names are all unique. Order by order date, ASC. Order ID over minus rank or dense rank. Let's give a dense rank over, again same thing, over partition by customer name order by order date, ASC. Rank हो गया. Now count of this minus dense rank of this equals to 1, or count of order ID equals to 1. We'll just need those rows. That's it. That's all that we need. Okay, let's run code. No, you cannot use window function count in this, sorry, in this context. Okay. Okay, then we'll have to use CTE here. No other way. CTE, or with CTE as let's start from CTE. In the meanwhile, I'm doing select star comma, then we will have count order ID ASC. This will be one row as count something over partition by ASC. Hey, this is done right. Yeah. Yeah, okay. AC as count order comma. We'll use another rank function, this one, as rank 1 something from orders. Okay, this is what my CTE looks like, and then from here we will select everything. Not everything, we'll just select order ID, sorry, order ID, order date, comma, customer name, product name, sales from CTE. Okay, so this is not needed. We'll just use maybe where count order minus rank 1 equals to 1. Minus rank 1 equals to 1 and rank 1 or count order equals to 1. Okay, fine. Should run. Let's check. Okay, order ID, order date. No, rather than 264, 164 came up. Rest and title is fine, but I think this has some issue. Okay. So count of order ID over partition by customer name, order by order date AC. Yeah, this is fine. Count order. Oh, okay. Sorry. I don't need order by here. I do not need order by here. This is just count. Yeah. Run code. Okay. Sorry. That'll be a cumulative sum. I need overall sum. This is fine. Yep. Cool. All right. Let's move to the next one. Okay. So the next question is department average salary. You are provided with two tables, employee and department, and the employee table contains information about employees, including their ID, names and salaries, and department IDs. The department table contains information about the department, which is understandable, including their ID and names. Your task is to write a SQL query which finds the average salary of employees in each department. Okay. But only include departments that have more than 2 employees. Okay. Display department name, average salary, round to 2 decimal places, sort the results by average salary in descending order. Okay, so the way I'm thinking about this is I will probably add department name on this table and then create 2 extra columns, which is average salary by department and also count of employee name, count of employee ID by department. And any department which has count of employee ID to be greater than equals to 2, I'll be picking out only those average salaries, right? Okay, so let's do this quickly. Select name. I think that's what we need, right? Okay, output is not given. I think we need this display department name and average salary. That's it. That's all we need. Okay, average of salary as average salary from employees join departments on okay E dot department ID equals to D dot ment ID. Okay, that's it. Okay, let's group by department name having count of employee ID to be greater than equals to 2, right? And I would have to round this to 2 decimal places. I can multiply by 1.00 or 1.0 and I can write 2. That's it. All will be same. And having count employee ID, and I'm guessing employee ID is going to be distinct because this is the employees table, this is the dimension table, not a fact. So there shouldn't be any duplicates. In case there were duplicates, so we would have had to create a separate temporary table where we would have taken department name and their count of employee IDs, distinct employee IDs, and then we'd have to match it. Right now, this is a fact table, so we're good here. Let's run code. Okay, average does not exist. Okay, is it average? That's true. Okay. What's the output required? Do I have to order it by something? Sort the result by average salary in descending order. Order by average salary. DSC. Let's try. Incorrect. Okay. What's the correct solution? Okay, let's read this. Including their ID and name, your task is to write a SQL query to find the average salary of employees in each department. Only include departments that have more than 2. Okay, strictly more than 2. Okay, got it. Sorry. My bad. Let's evaluate. Correct. Okay, cool. Okay. Please read carefully. Don't be like me. Okay, let's go back. Okay, so you are provided with two tables, products and sales. The product table contains information about various products, their ID, name, and prices. Basically, all the product information. The sales table contains data about sales transaction. The sales table contains data about sales transactions, including the product ID, quantity sold, and dates of sale. Your task is to write a SQL query to find the total sales amount for each product. Okay. Okay. That's it. That's all we need. Product ID and total sales using product name, and then sum of sales from products join sales on p dot product ID first s dot product ID. Results by okay. Sales in the field list. Sale ID. What? Oh, okay. Sorry, not sales. Price into quantity, right? As sales. Okay. Do I need to order by product name? Yes, that's also done. Evaluate. Answer is correct. Okay, cool. I think these are easy ones. Let's move on to the next one. You're provided with a table that lists various product categories, each containing comma-separated list of products. Your task is to write SQL query to count the number of products in each category. Okay, so furniture, product count is this, that. Okay, let's try to see the table first. Okay, got it. Okay, so here we'll have to apply one method called string split. Okay, so what should we do? We will use select category. Then we will use value as. Then we will use first select category. Then value as products from categories. Cross apply. So this is a method very similar to cross join, how we do. But since try to understand, electronics will be divided into three rows because the products, there are three different products, TV, radio, and laptop. So electronics will be cross applied to TV, cross applied to radio, and cross applied to laptop. So this way, we'll have to use this methodology called cross apply, and then we will use the function string split over products. Okay. And then we will provide the understanding that you need to take comma as the separator value, right? Let's not go. Now, what do I need? Finally, we need the count of products actually. We can take this directly. Count of value as products as maybe count products from this group by category. Okay, so this is what the code is. Okay, got it. So let's not do it this way. We'll have to create a separate CTA. CTE, sorry. Select category, comma, count of products as count products or something. Product count from CTE, or maybe first step. Oh, we cannot name it that way. From CTE group by category with CT as this. Okay, let's run code. An error. Check the manual. Apply string split. Okay, let's do one thing. Let's change it to MS SQL because I think cool, got it. Clothing, electronics, furniture, groceries. Sort the result by product count. Order by product count. DESC? No, ASC probably. Okay. Great. Okay, so what did we do? We actually took category, then we wrote value, which are nothing but products, and we are cross applying products to category. So instead of join, we are writing it cross apply. That means when products will be broken into separate rows, that will be multiplied by categories, and categories will be repeated basically. That's what it means. And yeah, that's it. And then we just counted based on category, so we are good there. So let's move on. Okay, so the next problem is Amazon notification. Your task is to analyze the effectiveness of Amazon's notifications in driving user engagement and conversions. Okay, considering the user purchase data. A purchase is considered to be associated with the notification if the purchase happens within the time frame of the earliest of the below two events. Okay, 2 hours from notification delivered time. Okay, next notification delivered time. Okay, so basically, let's say a notification is delivered at 10 a.m. in the morning. So if within the next 2 hours, which is 12 till 12 p.m., if any purchase happens, then that is attributed to the first notification. Or let's say there's another notification delivered at 10:30. So anything between 10 to 10:30 is a purchase that's attributed to the first notification. Otherwise, it'll be like if the purchase happens at 12, then it'll be attributed to the next notification, which is at 10:30. Okay, that's what my understanding is. Each notification is sent for a particular product ID, but the customer may purchase same or another product. Okay, considering these rules, write a SQL to find number of purchases associated with each notification for same product or a different product in two separate columns. Okay. So basically, let's say a notification is there, and then how many purchases are associated with that notification, and how many of those are for the same product, how many of those are for the different product. Okay. Display the output in ascending order of notification ID. So notifications table is there, two tables, right? Yeah, two tables. Notifications and purchases. So notification ID, delivered at, and product ID. Okay. And then there's purchase, product ID, purchase timestamp, and user ID. I don't think, do we need user IDs, by the way, for this problem at all? Particular product ID, customer A, purchase same or another product. Product ID and purchase timestamp is something that we definitely need. Notification ID is there because notification key with notification there is no user ID associated, so I don't think user ID is much useful here. Product ID would be the key which is used to compare notifications and purchases, and that's fine. Okay, so let me break down the steps here first. So first, what will we do? Since this is notification, so delivered at and purchased timestamp. What's the earliest one? Notification ID. Let's give a row number to notification IDs, no? Okay, create row number for notification IDs. Okay, to create row number for notification IDs. Yes, to mark them, to rank them basically, rank those. Then we will compare, let's say the first notification ID is there, delivered at, and purchase timestamp should be, okay, we need to take a lag, take lead of, sorry, lead of delivered time to understand the next noti, right? And also compare the or map, not compare, I would say map purchase timestamp, whichever are within 2 hours, right? That's for sure. Okay, so basically my table will be created something like this. So just to give you an example, let's say there'll be note ID, then I'll have, sorry, ID, note ID delivered at, then lead delivered at, right? And then I'll have purchase timestamp as well. Anything that happened, so delivered at and within 2 hours. Of course, like delivered at plus 2 hours is the range within which purchase should happen, and the product ID. The product ID is fine, and there'll be product ID, product ID. Okay, so here, one second, this there will be a prod ID and there will be b dot prod ID. Right? So when a dot prod ID equals to b dot prod ID, then we are counting that as same product, and when it's not, then we're counting as different product, right? So that's one. And lead delivered at. Okay, another thing. I think the main condition that I'm forgetting here is we have to choose either lead delivered at or purchase timestamp, not both. Right? So not both. That is for sure. So if lead delivered at is lesser than purchase timestamp, so that is a, yeah, exactly. So that is a row we cannot consider. So that's one filter. So lead delivered at should always be greater than purchase timestamp. Only then I'll be able to take the product. And so first of all, we are anyway giving the condition of within 2 hours. So this is fine. And then next condition is to compare lead delivered at and purchase timestamp to check that lead should be greater than purchase stamp, right? Yep. So that's what it is. So this is how the table structure should look like. And then finally, what will happen? We will count. So noti ID, each notification. Yes. Notification. So at notification level, what is the same product purchase count and different prod per chase count? I think this is fine. Can I comment this? Okay, I cannot comment this. Okay, I think you guys are understanding and able to comprehend the steps that I talked about. So let's write all those down and then we will, come back to the logic once again. I'm seeing that I'm not able to copy paste this, or I'm not able to, comment this out. So, yeah, got it. So let me put it out. Now let's start with the steps here. So first, what will we do? First, let's map these two tables with the condition that I just told, right? Even before that, I think it's better to create a row number. So with, let's say, with Rn as select star, comma, row number over ordered by delivered at ESC as Rn from notifications. Okay, so that's what it is. Fir, let's do the mapping. Mapping as select a dot star. What if I give this because I need everything? A dot star, comma, b dot product ID, comma, b dot per stamp from no sorry, rn a join. Just inner join is fine, I think, because we do not. No. I think we need to do left join because notification is the left table. Inner join is not okay because there might be some notification IDs and product IDs which are not there. So yeah, of course, left join. What I was thinking. Okay, purchases B on A dot product ID. No, A dot product ID equals to B dot product ID is not the condition here, but rather the condition is delivered at. Okay. This is timestamp, right? Okay, delivered at is also date time. Purchase timestamp is also date time, and that's fine. Even if I do um hours, right? So it'll be considered, I believe. So let's say on date and hour 2 comma delivered at less than equals to, sorry, yeah, wait, date and hour 2 delivered at is higher than product purchase timestamp. No, then everything will be added. That is not the case. So delivered at is 10, purchase timestamp is 12 or 11, both should be coming in, but 9 shouldn't be. I have to do where condition here. Hmm. From RN is fine, where date add hour 2 delivered at, sorry, purchase timestamp between date add hour 2 delivered at and delivered at. Okay, perfect. B is not needed. No, this is needed actually. Mm, wait, how do I give it? No, I can do that again. Sorry. Let's do on from RN left join purchases B on A dot delivered at, sorry, B dot purchase stamp greater than equals to A dot delivered at, right? And B dot purchase timestamp less than equals to add hour 2. Okay, perfect. So this is good. Then we need, so we have product ID, purchase timestamp, etc. We have RN, okay. And we need the lead as well, right? We can give the lead here. Lead of delivered at, over, ordered by. Hmm. Lead delivered at. Fine. So this is good. This is not needed. Then we are selecting basically aggregation as select product ID. Okay. We need product ID, purchase timestamp, user ID. We need notification ID. And whenever, let's say, notification is there, there'll be many delivered at which wouldn't have any purchase timestamp. That's for sure. Also, no product IDs, which is completely fine. And then we will check if A dot product ID equals to product B dot product ID, then that is same product. And if it's not, then it's different product. And also we will consider only filter out. So okay, select everything. Select star from, let's filter out. Okay. Filter as, select star from mapping where um, purchase timestamp. Purchase timestamp is less than equals to lead delivered at. Not less than equals to, less than lead delivered at. Okay, that's it. That's the filter. And then finally, I'm aggregating, saying select notification ID, comma, case when. So I'll do a count. Case when product ID, sorry, we have to name this as purchase product ID. Product ID equals to purchase product ID. Then one L0. Same product, same thing we will do. Product ID not equals to purchase product ID, then one else and zero. It's different products. From filter group by notification ID. Notification ID. We didn't use the row number. Yeah, because it might have been required in the delivered at column, but I've used this one only directly. So, okay, let's check. Okay. Line 33, purchase timestamp. Sorry. 33, purchase timestamp, purchase. Purchase. Okay. This is one. Anything else? Sorry. Notification ID 1, 2, same products, different products. Okay, let's see. Evaluation. What's your answer is incorrect? Okay. What's the output actually should be? Is there any expected output? 1, 2, and 3. So 1, 2, 2, 0 is fine. 3 has not even come. Okay, that's a surprise. So mapping, till mapping, I think it's fine. We have a dot star. We have select star where purchase timestamp equals to, okay, should I do this? Lead delivered at, let's run code and check. No. Okay. I think this is where the problem is happening. Let me debug. Select star from mapping. And I can, since I cannot, do anything, I have to copy it at some other place. Let me run the code and check. Notification ID 1, 2, 3 is still coming. Lead delivered at RN is something, that's fine. So lead delivered at is null. Delivered at, why is it null? 1 only, right? Yeah, delivered at 1. 118, 118, 118. Okay. 1030, 1030, 1030, 1030. 1 second. So here what have I done? Lead delivered at is 8 to 10. Notification ID is 2. That's fine. 10:30 and 11:30. Okay, that's fine. Lead is not there. Lead, nothing lead such as lead is there. So this is null. Okay, I get it. Purchase product ID and normal product. What's the normal product ID? It's P3. This P3, P3, P2, P2. Okay, that's fine. Purchase timestamp greater than delivered at. Yes, it is. And less than delivered at. Yeah, yeah, this is fine. Okay, so we have this. Then let's take filter then. Purchase timestamp is less than equals to lead delivered at. Okay, got it. So this is less than this, less than this. This is greater than this won't be counted. This is greater than this won't be counted. Okay, okay. So this is the edge case where lead is nothing. There is no lead. So I'm always checking for something which is higher than delivered at. Or lead delivered at equals to null. Got it. We can give this. Some cases, what's happening there? Purchase timestamp less than equals to lead delivered at, less than lead delivered at, or lead delivered at is null. We need to consider both because there will be some delivered notification timestamp after which there is no other notification which is delivered. So anything that happened after the first notification, that will be attributed to the immediate earlier one, right? So let's run code. I think this should fix the problem. Okay, sorry. 1 second. Okay, let me run the code now. What happened? Incorrect syntax. Fine. Yep, should be correct now. Let's check the evaluation. Yep, Cool. Okay, so I think all the steps that we talked about is pretty fine. We are giving the row number first, although I don't think it's needed because we are anyway ordering by delivered at, so that's fine. Then we are comparing purchase timestamp with delivered at and purchase timestamp less than equals to 2 hours added to delivered at. Finally, we're filtering for only those rows where, purchase timestamp is actually less than the next delivered at, or lead delivered at is null, basically because the comparison is null and void there. That's why we have to do this. So after that, we are taking notification ID and then we are checking the product ID equals to purchase product ID or not, and then we are counting the numbers. So I think our logic is pretty fine and we have submitted the answer as well. All right, so let's move on to the next one. Employee mentor. Okay, let's see. You're given a table employees that contains information about employees in a company. Each employee might have been mentored by another employee. Your task is to find out the names of all employees who were not mentored by the employee ID with employee with ID equals to 3. You're given a table employees that contains information. Okay, that's fine. I think ID, name, and mentor ID. Names of all employees who were not mentored by employee ID equals to 3. Okay, I think I get the trick here. So basically, we will select the IDs or name from employees where mentor ID not equals to 3 and or and mentor ID could be null as well. This should come. Anyway, let's run the code and check. Employees where mentor ID equals to not equals to 3. Or mentor ID could be null. Let's evaluate. Yep. So basically, we are giving mentor ID not equals to 3, and also we are including all the employee names whose mentor is not known to us. So this is an edge case again. So anytime you're solving a problem here, the input is visible. In many of the interviews, your input also will not be visible. So these are the edge cases that the interviewer wants you to take into consideration, right? Okay. So let's solve the next one. Project budget. So there are 3 tables here. You're tasked with managing project budgets at a company. Each project has a fixed budget and multiple employees work on these projects. The company's payroll is based on annual salaries and each employee's work for a specific duration on a project. Over budget on a project is defined when the salaries allocated on per day basis as per project duration exceed the budget of the project. When the salaries exceed the budget of the project. Okay. For example, if Ankit and Rohit both combined income make 200K and work on a project of a budget of 50K that takes half a year, then the project is over budget given 0.5 into 200K, 100K greater than 50K. That makes sense. So write a query to focus the budget for all projects and return label of over budget if it is over budget and within budget otherwise. Order the results by project title. That's it. So we need ID, name, and salary. I don't think. We need output to be, yeah, title, budget, and label. Okay, so we have employees, ID, name, and salary. Salary is yearly salary, and then we have projects, ID, title, start date, and date, and budget of the project. That's fine. And then project employees, project ID, and employee ID. Okay, this is just a bridge table. So, okay, so this is the employee ID, this is the project ID. So using this table, we will map both of these together. And the steps that I'm looking at should be Okay, should be, let's say, first map the three tables in like using the bridge table. Then think about employees and projects. So start and end date will give us months, right? Or days. Days is also fine. I think days is fine. Okay, so let's take difference of the start and end date to calculate the timeline of the project, right? In days. Then budget is already there. So now we will have to calculate the total employee salary. So for that particular project, understand how many employee IDs are there, right? So how many ever employee IDs are there, take their salaries. So group by project ID and sum up the prorated salaries. So calculate prorated salaries by using salary multiplied by number of days the employee supposed to work on the project divided by 365, right? Compare the sum with the budget and accordingly assign the labels, right? Finally order by project title. Perfect. Okay, so again, hope the steps are clear, and we can again come back to that and revisit this, or you can pause and come back in the video as well, just to make sure you remember the steps, or definitely try like feel free to try out your own steps as well. I think this is the easier one for you to break down each of the steps to be able to um, successfully complete the solution or problem, right? Okay, so let me copy the steps that I just told you. Sorry, my keyboard is not that great. Pardon me for that. Okay, let me go ahead and then write down the steps. So let's say start with mapping. Because this is a bridge table, you have to use it. So select a dot star, comma, let's say, okay, yeah, ID as the employee ID, right? Then I have a dot name as EMP name and a dot salary as salary. That is fine. Then we have, let's say, b.id as project ID. Then b.title, and everything else is pretty same, but still let's title as project title, comma, b.start date, b.end date, comma, b.budget from employees A join project employees C on A dot ID equals to B dot employee ID. Sorry, C dot employee ID. Then again join projects B on A dot ID equals to B dot project ID. Fine. So we are using this table as the bridge table, and then finally we are mapping all these values together. And this is like, I don't think here there needs to be any kind of left join, because we need to assign all the employees who are actually associated with the particular project. So we do not need extra, employees in the bench or projects which are shelved right now. So those information are not required. So just use join. So that's fine. So we have a mapping table ready with us. Then finally, what will we do here? We will take the ID, name, and salary. Yeah, so basically we have to calculate the salary here. So let's say grouped as select no, first I need date difference, because that is absolutely needed. Select everything dot star, basically a dot star, comma, date diff, day, comma, start date, comma, end date as difference in days, basically, from mapping. So this is what I need. This is number of days. And then what do I need? I need project ID, right? Because one project ID can have multiple employee IDs as needed. And then, so group by project ID. So I will use group as select project ID. Sorry. Project ID as sum of, we need that prorated salary. So salary by 365 multiplied by difference. Let's do this. Let's take difference as prorated salary, right? Yeah, project ID, and I need group by this one, comma, budget. Or actually, we do not need that. Anything which is less than, actually, it's fine. Let's keep it this way, separated, rather than case when and then again sum within. So that might be a little complicated query to read. So it's okay. We can use one more CT to simplify this. So whenever you are looking back at this query 6 months back, so it's easier for you to read through. So from, we are taking date diff group by project ID. Oh, I need title as well. Project title. Okay. Then I need select project title, or just title. Title, comma, budget, case when budget is less than prorated salary, then within budget. Else over budget. And as label from, yeah, that's fine. From grouped order by project title. AC, right? Yeah. So hopefully this is fine. Correct. So we are first mapping, then we are taking the date difference, then we are taking the grouped section. This could have been, merged together within one CTE. Also, the date diff could have been added here as well. Actually, yeah, we could add this here. date diff as difference because we are not this is not needed. We can just give from mapping. That's it. Okay, let's run code. Incorrect parameter count, date diff, day start, date end date. B dot start date. B dot end date. Incorrect parameter. Oh, okay, okay. I think MySQL is not supportive of date diff and all that. Project ID. Okay. Project ID. Project ID is there though. Project ID. B dot project ID. Not B. A dot ID. Wait, sorry. A ID equals to C dot employee ID. B dot ID. C dot project ID. That's what it is. Mapping budget is invalid in the select list because it is not contained in either. Oh, okay. That's fine. Project title and budget should be same, and then we can submit. Multi-part identifier project ID could not be found. Sorry, this is taking a lot of time. Project ID. From mapping. Project ID is there. C dot project ID. Okay. Analytics platform. Over budget. Okay. Within budget. Within budget. Within budget. Okay, this is completely wrong. When budget is less than equals to prorated salary. Prorated salary is within budget. Sorry. This is wrong. Prorated salary is less than equals to budget. Then within budget else over budget. Yeah. Yep. Within, over, within. Yep. Good. Evaluate. Sorry, it took a lot of time. Answer is incorrect. Why is that the case? Title, budget, and label. Within, sorry. Not so, within budget, over budget. Evaluate, sorry. Yep. Okay. All right. So hopefully this was, understandable. Let me know if you are unable to understand the steps that I took. I think this is pretty easy, although it's a little time consuming. So again, if you are trying to, reduce the number of CTs and make it more optimized, then make sure that the references or call to reference identifiers that we are using, like a dot, b dot, c dot, those are properly placed, because otherwise that can create a lot of confusion, and that will, the relationship mapping will become so difficult for you to understand and map along, and it can take up a lot of time in production. So give very much importance to the joins that you're doing. So which one is A table, which one is C table, and which column from A am I mapping with C? And when we are doing multiple joins in the same query, this can get really nuanced and a little complicated, which might take up a lot of your time when we necessarily don't have time. So definitely keep these in mind, and I think you're good. All right, so let's move on to the next question. All right. User session activity. You are given a table, user events, that tracks user activity with the following schema. Okay. User ID, event type, event time. Okay. Identify user sessions. A session is defined as a sequence of activities by a user where the time difference between consecutive events is less than or equal to 30 minutes. If the time between two events exceeds 30 minutes, it's considered start of a new session. Make sense? For each session, calculate the following metrics: session ID, unique identifier for each session. Okay. Session start time, timestamp of the first event in the session. Session end time, timestamp of the last event in the session. Session duration, difference between end and start. Event count, number of events in that session. So this is the table. We have user ID, event type, click, scroll, etc. I think there can be other event types as well, but I think this is of least importance to our problem. We have event time as well, when the event happened. Okay, so first what I'd like to see is I'd like to see the expected output. So there's user ID, then session ID is marked. Okay, session start time is 9, end time is also 9. Yeah, because the next event is after 1 hour. So that's not at the same session. So session start time and end time is same. Session duration is 0 and count is 1. Okay. And then next session is from 10 to 10:50. 10 to 10:50. Yes, that makes sense. And then we have duration to be 50. Okay. So if I'm understanding correctly, the main trick of this problem is to understand what is the start and end time, and then the rest we can figure it out. That's not a big deal. And the way, let's say if I write down the steps here, take user ID and event time and lag of event time, and then calculate the difference between the event and the lagged event time, and if less than 30 then 0 and otherwise 1. So create a flag. So we have to create session IDs as well. Remember, session ID is something that's nothing but an indexed number. Now I don't think we can give any kind of row number here because we do not have a logic how to increase the count. Or can we? No, we actually cannot. So we have to create a flag, and then we can take either, cumulative sum. So it'll keep on increasing. It'll create like counter system so that session IDs are automatically created. So once you create the flag, then we can get take cumulative sum of the flag, and then get the minimum and max of event time to be session start and end. Calculate difference between the two and count for number of events, right? That makes sense. Okay, let's start. So first, what will we do with it's lagged event as select star comma lag of event time comma 1 comma null over partition by user ID ordered by event time ASC as lagged time, something like that from say events, right? So we are sorted with one. Then we need the difference as well. We can calculate the difference also here. Do I do a case when? Yeah, why not? So case when date diff minute event time. No, first it'll be lagged event time because lag is previous. So comma event time less than equals to 30, then 0, else 1, and as flag. Okay, let's see how this forms. This I'm removing because I cannot comment out. So let's run code. Partition, sorry. Again. Oh. Okay, it's created. So user ID, event time, lag time, then flag. If it's then one again. Yeah, one. Okay. And then 0, 0, 1. This is not session. So how would I create the session right now after this? So I will create, let's say, cumulative sum. I'll take 1, 1 plus 1 will be 2, 2, 2, and then again this will be 3, 4, 3 will be a separate session. Yeah, this will be a separate session. Yes. This will be the same session, 12, 40, and 50. Yeah, okay, I think we're good. This logic seems pretty fine to me. Let's create sum of flag over partition by user ID ordered by event time. Again, ASC as session ID, right? From lagged event. And that's it. Okay, so sesh as, okay, so select user ID comma session ID comma max of min of event time as session start time, max of event time as session end time, and then count of star, right? Yeah, count star as event count from sesh group by same two, and let's order by these two as well. Okay, let's run. 1, 1, 1, 1, 1, 2, 3, 4, 1, 2. Okay, 1, 3, 1, 2. Oh, session duration. Sorry. Session duration would be just difference, seconds or minute or minute. Minute would be this. This is fine, I believe, because even within date diff, we are taking aggregated function, so should be coming under group by, not shouldn't be a big deal. Well, let's see. Session duration. Yeah. Count. Okay. Sorry. Okay, yeah, good. I think we are good. Hopefully you understood the problem. So answer is correct. Fine, great. So basically we are taking the user ID, creating the session ID. So again, just to recap, session ID is something which is nothing like an index. Now creating a row number based index here would have been difficult because this is not properly ranked per se. So what do I do? So if I start from ranking every other row, then 9, 10, 10, 20, 50, 11, 40, etc. Every event will have a row, and that's not great. Now here you can create a row number after the aggregation has come, but the aggregation in the first place wouldn't have come if you didn't have a session ID created. So I believe this is the only way to solve this problem. But please feel free to comment or post about your solution as well if you are solving this in any other method. Would love to know. All right. Okay. So let's move back and let's focus on all the other problems. Those are left. I think this video is probably becoming too long. So let's end this right now, and we'll continue and complete the only 3 problems are left, it seems, for the next video. All right. So take care. Happy learning and keep on practicing. Great problems.